Welcome to the lesson on isolation fault testing. In this lesson, we will look at how to use an insulation meter to test for an isolation fault in a BEV. Let us look at our lesson objectives. By the end of this lesson, you will be able to describe an isolation fault test and explain its critical role in ensuring safety within high-voltage systems. Next, you will be able to name the specific components that are susceptible to isolation faults. Then, you will be able to name the appropriate personal protective equipment, tools, and equipment needed to conduct an isolation fault test safely. Finally, you will be able to list and outline the step-by-step process for performing an isolation fault test in a BEV. High-voltage systems typically operate at around 400 volts or higher voltages, posing significant safety hazards if unintended electrical paths arise between the high-voltage components and the vehicle's chassis ground. Isolation fault testing focuses on detecting any faults that may occur between the high-voltage electrical components and the vehicle chassis or ground. This is particularly important because any such fault could potentially expose you to electric shock hazards. Isolation fault testing is typically performed during manufacturing, as part of quality assurance processes, and during the service or maintenance of the vehicle to ensure ongoing safety and reliability. Isolation fault testing is critically important in high-voltage systems for several reasons. BEVs operate with high-voltage systems, posing a serious electrical hazard if there is a leak to the chassis. Isolation fault testing helps identify these issues, preventing potential shocks or injuries. Isolation fault testing provides a vital tool to pinpoint the root cause of issues like power loss, decreased range, or unexpected shutdowns, leading to faster and more effective repairs. Manufacturers often have specific protocols for servicing the high-voltage system, and isolation fault testing is frequently a mandatory step. By following these guidelines, technicians can ensure their work meets manufacturer standards and avoid potential warranty complications. Components that could potentially leak high voltage are the high-voltage battery pack, the power inverter and converter, the air conditioning compressor, the power steering system, the electric drive motor, and the high-voltage cables and connectors. The high-voltage battery pack is the most likely source of high-voltage leakage. If the battery pack's insulation fails or if there is internal damage, it can lead to leakage into the chassis ground. The power inverter and converter convert the battery's direct current, DC voltage, to alternating current, AC, for the motor. A malfunction or insulation breakdown can cause leakage. If the air conditioning compressor is present, its high-voltage system could also leak if its insulation fails. Some BEVs use high-voltage electric power steering systems. A fault here could lead to leakage. A shorted or grounded winding in the electric drive motor itself is a potential source of leakage. Damaged or improperly installed cables and connectors can also create leakage paths. Insulation meters, also known as megoammeters, play a vital role in isolation fault testing as they measure electrical resistance, particularly at high voltages compared to a standard digital multimeter, abbreviated as DMM. The high voltage capability allows an insulation meter to evaluate the integrity of insulation in high voltage systems, where even small leakage currents can be dangerous. The meter can be set to various voltage levels depending on the specific component or system being tested. While a digital multimeter can measure resistance, its voltage output is typically limited to low ranges, under 1,000 volts. This makes it unsuitable for testing high-voltage components where leakage currents are of concern. On the other hand, an insulation meter provides the high voltage necessary to simulate operating conditions and effectively detect even minor insulation weaknesses that could lead to isolation faults. In essence, the high-voltage capability of an insulation meter makes it the ideal tool for isolation fault testing, allowing technicians to identify potential safety hazards and ensure the integrity of the high-voltage system. Let us now look at the requirements to ensure you are safe when working on high-voltage systems. Wearing appropriate personal protective equipment that includes gloves rated for 1,000 volts direct current, safety glasses and face shield, flame-resistant and arc-rated clothing, and electrical hazard safety footwear is crucial to ensure the safety of technicians. Utilizing rubber gloves rated for the electrical potential in combination with leather protectors offers a robust defense against electric shock hazards. Use non-conductive and scratch-free safety glasses and face shields to safeguard your eyes from various workshop dangers, including electrical hazards specific to BEVs. Flame-resistant or arc-rated clothing is crucial to your personal protective equipment. Flame-resistant clothing made of non-melting or non-flammable materials like flame-retardant treated cotton shields you from thermal hazards such as fires and intense heat. When working around BEVs or high-voltage electrical systems, electrical hazard footwear is necessary to protect yourself from electrical shock hazards. It is essential to have a BEV-trained assistant present throughout the entire process. This technician should be familiar with the specific vehicle model, understand high-voltage system protocols, and be able to provide immediate assistance if any unexpected situations arise. The presence of a BEV-trained assistant adds an extra layer of safety and ensures prompt action in case of emergencies. These safety measures help mitigate the risks associated with working on high-voltage systems and minimize the potential for injuries. Having and using appropriate tools and equipment is essential before performing the isolation fault test. A diagnostic scan tool can be helpful in retrieving fault codes stored by the vehicle's onboard computer system, which may provide additional clues about potential isolation faults. An insulation meter applies high voltage to the vehicle's high-voltage components and measures the resulting electrical resistance. The test leads are cables that connect the insulation meter to the vehicle's high-voltage system. They are insulated to withstand high voltages and have probes or connectors on the ends for safe and secure connections. Alligator clamps provide a temporary connection between the test leads and the vehicle's high-voltage system. They are useful when probing for test points or when the tested component lacks dedicated connector points. A rescue hook allows for the safe extraction of a person who might be experiencing electrical shock from a high-voltage component. A 1000-volt insulating mat provides a safe working surface to stand on while performing the isolation fault test. Window sucker signs can be placed on the vehicle to alert others of work being performed on a high-voltage system. Always remember to consult your manufacturer's recommendations for the components you are testing to determine the required test voltage. In this section, we will focus on the basic steps used for isolation fault testing in a BEV using an insulation meter. This is a brief overview of how an insulation meter is used to conduct isolation fault testing. Step 1. Refer to the manufacturer's service manual. Step 2. Use a diagnostic scan tool to verify the affected circuit. Step 3. Use an insulation meter to test the voltage. Step 4. Plug the probes into positive and negative ports. Step 5. Ensure the insulation meter reads 550 mega ohms. Step 6. Connect the test leads to view continuity. Step 7. Attach the alligator clamp to the tip of the negative probe when needed. Step 8. While testing inside the vehicle, use the metal bracket as a ground. Step 9. Test each lead on the stator winding. Step 10. Return the vehicle to operational status. Let us now look at these steps in detail. Step 1. Always refer to your manufacturer's service manual before you begin the isolation fault test, as the procedure could vary depending on the make and model of the vehicle. Referring to the manufacturer's guide will ensure you are following the recommended safety protocols and accurate testing procedures. Step 2. A diagnostic scan tool will be used to verify the affected circuit to test for isolation fault testing. When the circuit has been identified, the high-voltage battery may need to be de-energized or powered down before testing the affected circuit or component. Many BEV high-voltage systems are de-energized using only a scan tool. Some BEVs are de-energized by disconnecting the manual service disconnect, abbreviated as MSD. Refer to your vehicle manufacturer's service manual for the de-energizing procedure, as it may differ among manufacturers. Step 3. Choose an insulation meter capable of testing at a minimum of 500 volts. Before use, ensure that you read all instructions and warnings for your insulation meter. The available test ranges for this meter are 50, 100, 250, 500, and 1000 volts. Choose the range button for your meter to display 500 volts. Step 4. Plug the two probes into the correct positive and negative ports. Step 5. With the test leads not connected, press and hold the test button to view how your meter displays an infinite measurement. The meter will display 550 mega ohms when measuring an open circuit while set to the 500-volt range. Step 6. Perform a continuity test by connecting the test leads. With the test leads connected, hold either test button. The meter displays 0.0 ohms, an uninterrupted circuit known as continuity. Step 7. You need a good ground reference to perform the isolation fault test. Use an alligator clamp when needed to attach the ground test lead. Typically, the reference point will be to a vehicle chassis. Step 8. Ensure you verify the ground connection before every test measurement at a suitable ground location near your test point. As an example, we will use a metal bracket as a ground while testing inside the vehicle. When testing any high-voltage component with large capacitance or inductance, such as specific modules and large motor stators, it may be necessary to hold the test button for a few seconds, a minimum of 3 seconds, until the maximum resistance value is displayed. The meter should display 0.0 ohms, indicating continuity. Here, the device under test, abbreviated as DUT, is a high-voltage 3-phase electric traction motor. Two principal parts of a high-voltage electric traction motor are the rotor and the stator. The stator is stationary in the motor housing. The inverter switches the polarity of the electromagnetic field so the rotor begins to rotate within the stator. Note that the stator is not easily accessible in most cases without some disassembly. In some instances, the inverter must be removed to access the motor. Some diagnostic routines may have the stator tested from the 3-wire connection at the top of the inverter. As an example, for the purpose of this lesson, we will test the electric traction motor stator connector. The connector needs to be disconnected to disconnect the electric traction motor stator connector. Step 9. Use your insulation meter to test each lead. By performing this action, you add high voltage and low current from the positive test lead to the stator winding and attach the negative test lead to the motor housing or available chassis component. Hold either test button for 3 seconds to test the first lead. The meter readings should be infinite. As an example, in this lesson, the meter reading is displayed as 550 megaohms. As displayed on your screen, this process must be repeated for all connections U, V, and W. Step 10. When your testing is completed, determine the action needed. When all the repairs have been completed, return the vehicle to the operational status. Some vehicle manufacturers may replace a defective stator, while others may require the motor to be renewed. Always check your specific vehicle manufacturer's manual for the correct procedures, as procedures differ among vehicle make, model, and manufacturer. Let us recap what we have covered in the 10 steps on how to use an insulation meter to conduct isolation fault testing. Step 1. Refer to the manufacturer's service manual. Step 2. Use a diagnostic scan tool to verify the affected circuit. Step 3. Use an insulation meter to test the voltage. Step 4. Plug the probes into positive and negative ports. Step 5. Ensure the insulation meter reads 550 megaohms. Step 6. Connect the test leads to view continuity. Step 7. Attach the alligator clamp to the tip of the negative probe when needed. Step 8. While testing inside the vehicle, use the metal bracket as a ground. Step 9. Test each lead on the stator winding. Step 10. Return the vehicle to operational status. Let us now look at our lesson summary on isolation fault testing. Isolation fault testing detects potential leakage current in a vehicle's high-voltage system. The common leakage sources include the high-voltage battery pack, the inverter, the air conditioning compressor, the electric drive motor, and the high-voltage cables. Insulation meters are ideal for testing high-voltage components due to their ability to simulate operating conditions and detect minor insulation weaknesses. The main testing procedures for isolation fault testing involve de-energizing the system, selecting the correct voltage, and measuring the resistance between the components and the ground. Thank you.